Project 8, Homework 16. So let's get started. All right. So the question asks, theorem ABCD is a parallelogram and the diagram meets perpendicular, then ABCD is a rhombus. So that's the question states. It's asking you to just state the which is if ABCD is a parallelogram and it meets diagonally meets perpendicular, that's a given. And then they want you to show that ABCD is a rhombus. So here in this image beforehand, I already have my rhombus displayed. This is a rhombus. I mean, not a rhombus. This is a parallelogram. My bad. Yeah, this is a parallelogram, and they want you to show, is this parallelogram a rhombus? Can it become a rhombus? So, which also I have the diagram shown below. So, and the next slide. Here, state that it's a given, right? Given ABCD is a parallelogram, and the bisector meet perpendicular. So here we have here we're showing the givens in the diagram from the previous slide, right? I have AB is parallel to DC and AD is parallel to BC, right? And our show in which we want to show ABCD is a rhombus. So we're going to try and create a statement or a proof to show that ABCD is a rhombus, all right? For statements and justifications, right? So let's start with the first one. ABCD is a parallelogram and diagonals meet perpendicularly, right? Well, the first thing is because the first step is one, it's given, yeah, because it's the given. So always making that mental note. Whenever something is given, that's probably going to be the first step. Any case, also, there's also some cases in which it could be another step, it could be another step, or it can be another step. However, it's going to always be the first step. All right. Next step. AB is parallel to DC and AD is parallel to BC. Why is that? Oh, it's a definition of parallelogram. Step 2 is a definition of parallelogram. Why? Because the definition of parallelogram states that the top and the bottom of any parallelogram. In our image here, it's going to be parallel to the bottom, right? Our top is always parallel to the bottom. However, our sides aren't parallel to our top and bottom, they're parallel to each other. So in this example, right, AB is parallel to DC and AD is parallel to BC. All right. Step 3, measurement of angle BAC equals to measurement of angle DCA. Why is that? Give you guys a couple seconds, just think about it. So if you guys think about it already, it is based on the ulterior or the ulterior angles theorem, in which we have these two angles parallel. These two angles are congruent to each other. All right. Step 4, measurement of angle DEC is equal to measurement of angle AEB. All right. So we have our DEC and AEB, right? Why is that? Take a couple seconds to think about it. I'm assuming you guys already did, so let's go with that. It's based on the vertical angle theorem because both of them are equal and both on the exact same point, which is this point E. Triangle DEC is congruent to triangle BAE. So is this triangle congruent to this triangle? Let's take a moment and think about it. How is that possible? How is that possible? Think about it. All right. I'm assuming you guys paused and thought about it, but if not, that's all right. probably struggled. Now I'm gonna give you the answer, right? So the reason for that, it's angle side postulate theorem based on step 4, 3, and 2. Why? Because, well, we have our vertical angles, right? That's equal to each other. Arbitrary angle theorems, these two angles are also equal to each other, as well as our two sides are equal to each other. Why? Because a definition of parallelogram, so it makes sense. Step 6, CE equals to AE, right? So we have our CE equals to AE. Why? Well, and also, here's another one. DE equals to EB. Why is that? Take a moment, think about it, and think about it. All right. Well, thought about this correspondent theorem, right? Why? Why is it? Oh, you see our lines, right? We can think about this in two ways. I put in the correspondent theorem. Why? Because for me it makes sense. It kind of rolls with it. If it doesn't, there's also another reason why. Because you see here our A and E, right? It has to equal to that, right? It has to equal to this, right? I'm going to explain it with the triangles, right? See, these two lengths are equal to each other. Why? Because our center point is E. Everything's focused on that E. So this is like AC is the full line. That's the full line, right? However, we split it off at point E. So AE equals to C, right? As well as here, as well as with our other line, right? DB, that's the whole line, right? However, we split it in half based on also the based on perpendiculars, right? Since AC is perpendicular from DB, right? So that's they're gonna have equal lengths, right? They're probably gonna have DE equals to EB, right? Or BE, right? That works. And also if AE has to equal to CE, right? Yeah, because of correspondence, but also based on triangle, right? Because since this is congruent to this, since this is congruent to this, and this is congruent to this, so kind of makes sense that this equals to this, and this line EB has to equal to ED or DE and BE, right? Because they both lie in the exact same line. All right. Step 8, line measure of angle AEB is a right angle. Why is that? Think about it. You probably thought about it, and it's because of the given and also step 1. Well, it's step 1 or the given, either or, because they both meet they meet perpendicular, right? It meets perpendicular. So since we did that perpendicular, so it's going to be a right angle, in which this step 8 is going to lead up to another step 9, in which since both of these angles do meet, right? They both meet midway and also meet bisectorally, meet at a perpendicular angle. It's going to make step 9, which is AC perpendicular bisect to DB, as well as DB is a perpendicular bisect to AC, right? And which we stated before, right? Definition of perpendicular bisect. Why? Well, because if we just split this in half, right? If we just AC, right? This is our line AC. It been bisected by DB. So vice versa with DB, right? Our whole line DB is being perpendicular bisected to AC by AC. So thus we have DB ABCD is a rhombus. Why? Well, it's based on definition of rhombus. Why? Definition of rhombus states that when all four sides and the lengths are equal to each other, are equal. It's very clearly right. Here we have this triangle with this angle, right? This line equals to this line, right? As well as this line equals to this line, right? And these vectors are equal. And these lengths, right? This length equals to this length. So these have to be equal too. However, using the previous theorem, as well as this is a 90 degrees, that means this has to equal to 90 degrees also, and this has to be equal to 90 and 90. So they all have to equal to their same angle. So that means they have to share lengths, as well as since we know both lengths, right? Since everything is here shown, definition of rhombus, right? So here we have ABCD is a parallelogram, right? Why? Because of given, yes. 2. AB is parallel to DC, as well as AD is parallel to BC. Yes, why? Definition of parallelogram. All right. Angle BAC is equal to measurement of angle DCA. Why? Ulterior angle theorems. Yes. 4. DEC equals to measurement of angle AEB. Why? Vertical angle theorem. 5. 5. Triangle DEC is congruent to triangle BAC. Why? Angle side theorem, which is based on step 4, 3, and 2. Because we have a 4, right? That's an angle, and that's a side. So yeah, that runs. 6 and 7, they work the exact same reason. Why? Because line segment CE equals to segment AE. Why? Because it corresponds to sides, because it corresponds because of step 5 also. Step 8, measurement of angle AEB is a right angle. Why? Because step 1 or the given, either or makes sense because step is the given. Why? Because the diagonals meet perpendicular, so since they meet perpendicular, that means this has to be equal to right. This has to be equal to a right 90, to a right angle. Tilt this to a little bit, tilt to the side. And you see, oh, it actually looks right angle. Right? And then step 9 states line AC is perpendicular bisected to DB, and DB is a perpendicular bisected to AC. Why? Because it's a perpendicular bisected, because you see based on the diagram, this entire line for DB, right, is being bisected by AC. Vice versa applies. AC is being bisected by DB. And ABCD is a rhombus. Why? Definition of rhombus. Why? Definition of rhombus states, work this out very thoroughly, or very actually work thoroughly. We can discover that these lengths are equal to these lengths if we just keep on working on this side, right? Because it's this length equals to this length, and this length equals to this length. We go like, wait, so that means this vertical, this angle has to equal to this angle, and this equals to this angle. So since that these two lines are equal, however, these two lines are also equal, right? Naturally. So, and that's all it. And from the previous slide, thank you. Thank you so much, and